I'm Dr. Mainul Hussain, Assistant Professor, Department of IEEE, University of Dhaka. So today our speaker is Dr. Shafi Khadem. He is working as a leading researcher in the Embedded and Distribution Generation Systems Group in the International Energy Research Center. Okay, and Dr. Khadem today will be talking about integrated energy system solutions for smart energy communities. So before we go into the talk, I have the pleasure of introducing the speaker, Dr. Shafi Khadem. He leads this group of embedded and distributed generation systems in the International Energy Research Center at Tyndall National Institute of Ireland. So his research is basically focusing on the area of smart grid networks with a special focus on grid stability and power quality, distributed energy resources integration, microgrids, VPP solutions for smart energy communities. So his interest also includes grid services, local and wholesale energy markets. He has been serving as a principal investigator, lead researcher, and work package leader in multiple national, European Union, and international projects. So he's a member of the European Technology and Innovation Platform for Smart Networks for Energy Transition and a senior member of IEEE, the Power and Energy Society. He's also the associate editor for the IEEE Access and national lead of IE Tax and Geo. He is a former alumni of the Department of Applied Physics and Electronics at the University of Dhaka. So, with no further delay, I would kindly request our speaker to start his talk today. Thank you.
Okay, thanks, Mainul, Atik, and all. It's really my pleasure, I would say. Um, so I'll be starting this talk, though the topic says this is integrated energy system solutions for smart energy communities. So uh, uh, first of all, I would say this. I'll try to give a kind of broad overview uh, in the whole energy systems networks, kind of just to have some sort of flavor that why we are really thinking or doing some sort of research in power and energy groups as this group belongs to this IEEE department in Dhaka University. So and to give some sort of, I mean, the idea is to go um, mainly for the students who are in this department and trying to enrich their knowledge and research and in the future career in these power and energy sectors. So it will give you some sort of kind of overview and encourage, I believe, that you'll have and in future it will make some part also for you for future work and to look at how the global work is actually going on. So I'm not going that much details and technically right now. I mean, the today's as kind of this is just a kind of introductory information to sharing with you. So, but don't feel shy to ask me any questions. So if you need to go for any kind of further details, definitely I'll be happy to go uh, in details with topic by topic. But yeah, it's everything will be depends on students' interest and those who are actually also listening here. So the point here first is just thanks, Mino, for the long introduction for me. That's really, I would say, uh, big um, encouragement from me as well. So with time, actually, when I finished my degree in Dhaka University, by this time it's already gone around 20 years. So time just flies. And the way we start during that time we did not have this sort of power and energy issues and things and all this knowledge. So what I learned basically after this my degree and doing some sort of research and feeling my interest. So all the way I would say that the very first point is whatever you want to try to do, you should have a good passion. If you don't have any passion, you really can't do any kind of research work. That's the very first point I would say. So I'm just trying to see if it is in the power slide mode. Sorry. Can you see my big screen now? Full screen mode?
Yes, yes. Thank you. Thank you.
Okay, okay, that's great. Thanks. So before I go to the details about these specific topics, as I said that this is a very big and broad topics and that covers a lot of things, but I'll just go a kind of very little overview things that how really global is thinking and what they're doing and trying to do as well, and what their planning is. So if I don't know how much all these students and all of you are familiar with these different, initiatives or the terminologies that will be used in this lecture. So, but I'll just focusing on so that in future we can really go into details and depth and depending on your interest. But you will learn a lot of terminologies here and the things that how really it works. So when you talk about this global uh, point of view, that what really is people are trying to do in the clean energy transitions, there are lots of initiatives that is taken by these global organizations. It is started from the national, from the European level, from the global, the whole uh, global point of view, the international point of view. If you see that there are different types of, I would say this organizations and initiatives that's linked together here to each other. So from national, from to the European, and then from the global level, how they're connected to all these things. Their main focusing point is to go for clean energy transitions. What does it mean really? So the global energy transitions is all about that's how whatever you're using your power and energy in this your daily life and these overall your thinking and working and in any space. So how you can make it from a clean source. So all the way we all know this sort of global warming, GHG emissions, all these things, and we know by these times there's okay, renewable energy is very much important, and that's one of the source for this clean energy. So whole network, how you can really transfer to this to be operated from the clean energy sources. So when you say this renewable energy and clean energy sources, there are some sort of little bit other uh, points or characteristics included there. Okay, in some spaces you'll hear this distributed energy resources. So all this terminology comes with their little bit changes with the definitions and characteristics. So we'll be talking this thing, throughout our time that how we deal with. But here the focusing point here is if you see that's the clean energy ministerials here, mission innovations, innovative challenges. Okay, then the IEA International Energy Agency's technology collaboration program. So these are kind of more important global initiatives. That's the global means lots of countries globally involved from the high official point of view, and they are taking more policy and strategic views that how really the whole energy systems can be transformed to a clean energy solutions. So all the way they're trying and thinking that's by 2050, if it is possible to move these, removing all these uh, unclear or these fossil fuel based solutions to a clean energy based solutions. So it's not only from the generation point of view, from the consumption point of view, and all the way the whole networks. So that's the things from the global initiatives point of view. So they are taking different initiatives and different tasks. All these they have different subgroups subgroups and subtask level. So then it comes to the European, when it comes especially, I mean, I'm just talking as I'm now in Europe, and it's trying to link with these European initiatives, and definitely there are some others also from the US point of view. I mean, the North, they have some other initiatives as well. So from the European Union point of view, they have some sort of European set plan, which defines that what type of activities you should take. And from their point of view, that's by 2050, you want to decarbonize your whole system, how you can do these things, where you should focus on, and what they have all these specific, I would say there's step-by-step procedure and the plan. And every year they update these things. Okay, by 2020, how much you should achieve in your renewable energy target, in your uh, GHG emission reductions, in your energy efficiency issues. So all these things actually covered. So then they launched a big program in Europe. If you, I don't know if you heard about these things, the Horizon 2020, it was the last 7 years program in Europe, the biggest research R&D program, where they funded billions of euros for research purposes. All these European countries compete for these collaborative projects and fundings, all these things. So this year, from this year, it turns into Horizon Europe. So next 7 years, they will run this Horizon Europe, where they will be investing more than 100 billion for this research purpose. And their target to achieve by 2030 at level of renewable energy integration to the whole European network, and lots of other activities also. So, and here you see there's ETIPS. This is the European Technology Integrated Platforms, where they have different initiatives and different subgroups for looking after these specific points on these issues. So on the national level, then each country have their own initiatives, their own departments. Like in our country, we have the Sustainable Energy Authority in Bangladesh, I think. So in Ireland, they have also Sustainable Energy Authorities in Ireland, and they have the government of Department of Climate and Energy. So, and all other departments, those who are relevant with these areas. So they have a specific target, and they invest as well in R&D point of view. I'm focusing more on this from the research and development point of view. Okay. So then all whatever they decide or whatever they want to do, that's linked with their European target. And that's also linked to the global point of view. So you see that's how they are really integrated. So it's not only just they're thinking and then planning for their own. So it's all about the link
Shafi,
every way. Yeah.
as one just mentioned, one person, one at a DZ, I mean, your voice is a bit lower according to, I don't know, but to me, it's okay. So if possible, just,
Sorry.
uh, yeah, no, it's okay. For me, it's okay. But he said that, I mean, for him, it's so just to share, I mean, in case.
Okay. Okay. Is it
Yes,
okay
thank
now? I'm not sure. So
you.
I'm
It's okay. It's
trying
okay.
my best as loud as possible, but and I'm using my microphone as well to make it better. So I hope. But yeah, just let me know if there is any kind of problem in hearing, or anywhere I need to pause or a little bit slower or anything. So just please. And I'm in the fully screen mode, so I can't really see if there's any kind of message or anything. So just if someone shut me, that should be fine. So now just from the European level, as I said, there's the one initiative is this ETIPSnet, where it's a European Technology and Innovation Platform for the smart network for energy transitions. They are one of the biggest platform in Europe, where they have dedicated tasks to defining that's how by 2030 the whole network can achieve at some level in their decarbonization issues, and by 2050 how they can achieve. You see they have their roadmap. So luckily I'm involved on that group as well. So they have different working group under this, and I'm working on this working group 5 on this innovation implementation of this business environment, mostly focusing on the project outcomes, that how they're really going to the market. So it's high tier level work. I'm not sure how much you're familiar with this. I mean, the terminology. So TRL is technology readiness level. This is very, very important in terms of the research and innovation space to go to the market. How you research, you can commercialize and go for real product. So that's defined this TRL, technology readiness level. They have 1 to 9, where if you have some sort of idea that define that's in TRL 1 and 2, very early stage. So you have some idea and you want to do some sort of very basic research. Okay. So when you do some sort of laboratory experiment to validate your things, that goes to TRL 3, 4. And as you go up in bigger scale demonstrations, so it goes to the 5, 6. In real life demonstration, when you go, it goes the TRL levels 7, 8. So 6, 7, 8. So that means you validate your solution, what you are trying to do, and that is ready for the market. So what TRL 9 indicates that it is ready for the market. So that sort of mechanisms they follow here. So that's the way actually works. So that's one of the initiatives that they detailed, define this R&D, what the research development and innovation should be done in the next 10 years, for example. And each year they update their plan and what type of improvement has already been done in the European countries overall. They analyze all these things. So that's the details they do, sorry. So that's and you see there's a group also national stakeholders involvement, so each country have their own participation there as well. So this is from the European point of view. So this is another one just at the national level, how it works. Okay, so this is the Sustainable Energy Authority of Ireland, as I'm based in Ireland, so I'm mostly involved with them, and they have their own strategy and own plan to go ahead to meet the national requirement. So, and they have close link with the IEA for the global point of view. And that's managed the IEA technology program, what they defined, the task that comes through this national agency or national body to the at the national level. So I'm also involved there. So I'm taking a task lead actually for national lead for this global observatory of P2P. I think lots of you have heard about these terms by this term, P2P, peer-to-peer communications, consumption, energy trading, all these issues. So how the consumer can really trade with their energy. So on that program, I'm the national lead here. So that's one of the involvement. So that's by these times, actually, I have a good understanding that how all these things really work and how all these are connected together. Okay, so that's why it's very important to learn, to know that's what really you can do and what we actually in our country we are doing in Bangladesh, and what really we can think about more, that why you are in this energy and research areas, power and energy side areas, that how globally they are thinking, how European people, I mean the initiatives they are doing, and the or from the country level of view, how they're doing. So if you just think about this, this is one of the very clumsy schematic, I would say. Okay, that's how they vision by 2050 the decarbonization of the whole network. Okay, so what really in the European level they're thinking about, what this diagram means, shows. You see this network, there's the electricity, heating and cooling, gas, data. They're the basic fundamental or the backbone of this whole network. So just give you some sort of brief overview of these things, that what they're really thinking, what are the core of this vision and how to achieve really. Okay, so one of the important thing is you see this whole network at some space, as you're thinking that to decarbonize the networks. So that means you have your electricity requirement, you will have your thermal energy requirement. Okay, you'll have your transportations energy requirement. So you'll have your water energy resource requirement. So all this energy you have to fulfill, but that that their target is to integrate the whole energy requirement and to decarbonize the whole things. Okay, how to do these things, or what they can do really, is it possible or not? So their target is by 2050 to do these things. So that's their main focusing point here, that you have to have lots of generation sources, different types of distributed generation sources, and that has to be connected in different space in the network. If you remember in the last if I am in the last lecture by I think Mustafa, I was not there, but I later on I have the opportunity to have his lecture that was really very good, and gives the kind of very good basic information about the whole power systems, smart grid areas. So that was really helped me to push or go beyond these things to give you some sort of overview of the whole thing. So I think by this time you have some idea or some understanding of these things. So distribution network, transmission network, and how the distribution as happens, and what are the other issues about this cyber securities, why it's coming. Okay. So we will be now, I think you can understand a little bit more about these things with time, and that will be really interesting, I would say. Okay. So now see that how these distributed resources will be connected into the whole systems. It's from the generation point of view, from the very high voltage transmission network. It could be connected to the distribution network. Okay. Even at the consumer end, those who are using, I think by this time you know this, what is prosumer. So consumer who is consuming energy, all these end user, we are consumer. But at the same time, if we have our PV panel at the roof or in our premise or some wind turbine, and we are using our own energy, our own clean energy, so that means we are a prosumer. Prosumer means producer plus consumer. So that makes as a prosumer. So now considering this thing, so their focusing point is that this type of generations could be connected in anywhere in the network, from the very high voltage to the very end, very low 220-volt networks. Okay. And there's good possibilities to integrate lots of distributed resources in the very low voltage network. So, which is very much challenging in future to handle. Okay, so we'll come on that later on. So that's one of the things. Now, from the conversion technologies, as we said, they are not only thinking about these electricity productions, but it should cover the other energy sources, I mean, the requirement as well. Thermal energy, transport energy, all these things. So then you have to focus on these conversion technologies, like power to gas. Okay. So power to liquid, power to hydrogen. So all these things. Now, by 2050, you'll have lots of storage, electricity storage, I mean, the energy storage solutions in your network. Again, all these things will be in the high voltage network, medium voltage, low voltage network. So it could be, and all the way you have to connect it. Otherwise, this is one of the vital solutions. I mean, this is storage, integration of storage into the network. Otherwise, you really can't do any kind of your target. I mean, you can't achieve your decarbonization target. Okay, so nowadays I would say these decades importance of integration of storage in the networks is really getting very, very much importance. So I hope it's okay to carry on. I am hearing some noise. There's some noise from someone's place. Maybe it's better if you mute your microphone, please. So the other important point is digitalizations. Without this, you really can't do anything. you have to have digitalizations, your data and communications, your ICT solutions, all these things. And you can't do anything with your cybersecurity if you don't have this digitalization solution. Okay, so all these things you have to have. So all these things should be happened by 2050 so that the whole systems can be decarbonized. Okay, so then final point comes that the consumer, who are the user of this energy, basically why we are doing these things, or why we are taking care of all of these things to decarbonize the whole system network. So it's because we are the user, and we are the very important issues of this whole network to decarbonize. If the customers are not fully engaged with the whole systems, then it may not be possible. So all these consumers and users have to be active consumer, and they have to take part actively in all this game. Okay, so they have to have their productions, they could have their excess energy, they want to sell these things, they want to transfer it to the network, so network has to be able to adjust it, adopt it, to get all these things done. So they have to take a very much active role, and we'll see more on these things. Then the buildings, all these buildings and industry, they also consume lots of energy. It's not only for the consumer, but all for the other users as well. Okay, so they have to be active as well. So you should have some sort of passive building house, emission buildings. So these sort of things you have to develop. And then the transportation sectors. Okay, so all these things require lots of energy. So how really you can fulfill all this demand by developing your decarbonized smart grid network? So that's for the from the European point of view. So similar thinking is actually doing in US as well. Okay, if you think about, if you see, there's one kind of just a basic architecture from this developed by Unreal for Department of Energy. So they have their similar type of thinking and plannings. There's the regional, how the region is connected to the cities, and cities is connected to consumers. So how each are really interconnected to go for this type of system integrations or integrated energy systems, if we say, okay, and how these are connected really. That's developed from the EPRI. So they're just thinking and taking actions similarly. So now come back to the European gain. So that is their final target is actually. So electricity network will be the backbone of these integrated energy systems solutions. Okay, so where electricity is the main or the core of these systems, and all these other networks, other these conversion systems is connected to the electricity, and you see all these generations are connected, and then here is the consuming solutions. So all these things you have to connect it, and all these are really fulfill your energy and power, and that's the things you are trying to do in the research work. Okay, so what then should be in the future integrated energy systems, and what they need? So basically, if I say that's okay, we need the clean and distributed energy resources. We need the energy conversion systems, we need the energy storage, we need the digitalizations, and more active energy consumers. Okay, so how you can really do these things? Okay, we'll come back to these things. When you see that's when you talk about this energy active consumer, as we say, that's they have to be active and they have to produce their energy, or somehow they have to respond with the energy, and they can um, trade their energy with the other consumers or other participants. So there, then the whole market will change, the electricity market, okay, the energy market. So if we see these things, so these are the very core or the fundamental requirement to have all these things happen. So digitalization infrastructure, physical layer, the physical systems, and here it is comes the communications, and that's linked with the market. So this market is energy market, okay, not our shopping center. So that's but it's basically works like that. Okay, so as you know, there's, I don't know how much you're familiar with this wholesale energy market or the retail market. Okay, so we are all using electricity, but we don't know how really it's happening. Okay, how the bulk amount of energy, where it is producing, who is using, how it is balancing, all these things. Okay, so that's things actually dealings with this wholesale energy market. Okay, and then when it comes to the distribution level, at that level, the utility supplier, they actually deals with this retail market. Okay, so up to this two part is more or less existing in all over the world. All the country follows these things. Okay, now when you are trying to connect your customer, you are saying this, you have to have active energy and active consumers, and you want to connect them into this whole systems. So that means you have to allow them to participate in some sort of energy trading, and that you can do through your local energy market development. So which is currently one of the focusing point or the research areas that's the EU is working on, that how to develop this local energy market and how really to integrate all these consumers into this space. So there are different sorts of I mean, the vast area of research in this field as well. So it depends on your interest, or we go ahead or not. Okay, so we'll be touching some of these things sometimes. So what are these really opportunities? All why we are trying to do all these things? As we said this in a very basic form, if we say that's okay, in 2010 we have very little of renewable energy integration in our systems. Okay, and we have very low circularity. So recycling is one of these other aspect actually also from the environmental point of view. So we are not going on that directions, but that's the things actually look like that by 2050, you'll have all these things from as clean as possible from the green. Okay, and that's the things. So the main opportunities, I mean, they would say that it's like this. Okay, from the synergy point of view, it's connecting all the energy domain. When you talk about this integrated energy system, it's connecting all the energy domains. And the streamline is improving within these energy systems, and more importantly, it's empowering the customer and the consumers. Okay, so customers' participations, that's really very important. Okay, so all the way that things happen, their plan. This is just kind of to show you that's how the at national level, they also have their plan. Like in Ireland, by 2050, they are trying to decarbonize their smart grid network, the grid network. Okay, so how to do these things, what is their plan and how to achieve, where they should focus on. So all these things, you see this mapping they did, and they have all these details calculations, and they are targeting to achieve these things accordingly in time. And that's also linked with the EU target. Okay, so if you don't fulfill your demand, like for example, if I say that every country now develop their national energy and climate plan under the EU regulations, all the EU countries, like EU decided I mean, from the whole European point of view, European Commissions, they have targeted by 2030, you'll have 40% electricity from your renewable sources. 40% of electricity should come from the renewables. By 2020, it was 25%. Some countries it is 30%. So it depends on, but EU generally define these things. So each country has to fulfill these obligations. So each country then have to take initiatives. They're doing research, their installment in improvement, everything they have to invest to achieve the target. Like by 2020, Ireland has the target to achieve this 30% of renewables from the electricity, which they did not fulfill. And their CO2 emission reduction should be there. And EU penalized these countries if you can fulfill your CO2 emission reductions. Okay, so like Ireland is now giving penalties for these things. They missed their target last year, so they said they have to pay around I forget the exact figures, some sort of 200 million euros to other countries who actually cross they fulfill or who can barely compensate. So that's one thing. But all the things, as you said, just how strong they are, and they're really trying to achieve these things, and how much involvement they are doing. Okay, they're working on. So that's one of the things that how they really want to achieve. So now, when you talk about this smart grid network, okay, you see just how European unions, all these countries really connected. They have their link and connection all the way. And there is even now working more to get all these whole European Union to develop this smart grid network, and all are connected together. And the target, what they said is by 2050, uh, to decarbonize, it's not only the decarbonization of this network, it's all about the active participation. Okay, I'll come back to that point there. But when you talk about this smart grid, okay, we said this, maybe I think, yeah, that what really it is. So very fundamentally, if you just think about this network have two structure, okay. One is your electrical infrastructure, and the other one is your ICT infrastructure. So these two are overlapped each other. When you have proper working of these two layers, I mean, that's important to develop your smart grid network. So a smart grid network is always talking, always changing. It's all about the real time. Whatever happening, whenever you need anything, so you can immediately do and take some actions on these things. Okay. So why this type of things is important, or why you are talking this smart grid network? Okay. So if you think that conventionally how the network is works, you have your generation. I think in the last presentations you have seen already. You have your generation, you have transmission, then distributions, then consumptions. That is the basic backbone or the basic structure. Okay, and it's unidirectional. It was. Now it is past. The present is it has to be bidirectional. So what does it means? Means that consumers at the consumer's end, as you are now trying to introduce your micro generation solutions or any other sources, clean energy sources in the low voltage distribution network, that means you have a chance that current goes in reverse. Like you have your PV panel at your roof, and at some days you're in holidays, you're not using any energy, whatever they're generating. So it's going back to the grid network. So it's flowing reverse way. Okay. So each of these substations, I assume by this time you already know about these things. Okay. Each substation should be capable to handle these things. So each substation's transformer have their own rating and own capabilities. Okay. So now how much really you can do? So that's one of the biggest challenges in everywhere. Okay. If you want to accommodate lots of renewable energy or clean energy sources in the low voltage network, how really you can maximize it? There is a limit. Definitely you can't. Okay. In normal practice, if I say this, okay, in substation, the transformer is, for example, whatever the transformer rating is they allow 15-20% of that capacity to install the renewable energy sources into that network. Okay. In some spaces, it's 30%. Okay. But if you go more than this, it makes trouble in the network. It creates some stability issues, some power quality issues, that sort of things arises. So that means you have to do lots of research in these areas as well. So there are plenty of things to do. Okay. So it's very easy to say, okay, what I'm saying, all these things. Okay. But it's really very much challenging, and lots of things are people are doing really, and still lots of things to do. Okay, so that's the things you have to take care of, and we have to think about in our places as well, and from our side that how much really we can do. Okay, so as I'm saying, that's to the student and the researcher, those who are working and trying to work in these areas. Okay, so all the way smart grid ensures that's an efficient sustainable electricity supply with lower loss and greater reliability and security. Okay, so you can learn a lot of things and more these things. Most of the places I put some references as well, so you can take these things and have a look. So with time, we can deal more on this and discuss more this. This is another things that, as you see, that's when you have electricity and the ICT is linked or overlap each other, then lots of issues comes. Okay, and what the way, and you're thinking about for active participations to develop some market and all these things, develop some control and operational issues. Okay, so then basically some sort of, you know, this standardization bodies is there for any things, for any work. Okay, whatever development you do, we should have some sort of standardizations. So similarly, the smart grid areas, there are different sort of standardizations practice globally. And some of these are like from one of these things is from the US NIST, National Institute of Standard and Topology. They have some smart grid conceptual model. Just let me know if there is any kind of yeah problem from anybody's side. Then there is the IEEE organizations who also have their own standard development in these areas. And the other one is also the smart grid architecture model, which is called SGM. Okay. So that's actually talk about the different layer. They put these things that how your generation, transmission, distribution to your customers in different domains, if you put it there, and what are these zones that they work. Okay, the process field station operation, and how it's really can put into a kind of interoperability. That is one of the important issues. Okay, why it takes on interoperability issues, because you have lots of communications and response in the whole smart grid areas. Okay, wherever you want to do anything, even the consumer want to change their anything, so they have to have some sort of response and from somewhere. Your network operator could sense, I mean, they send you a signal to do these things or that things. So you should have some sort of these issues, or even if you want to exchange any information or anything. So that's where these issues will come. So all these things require that system to systems level in connectivity or communications. Okay, so that defines these interoperability dimensions. So then they put these things into a different layer, like component layer, communication layer, information layer, function layer, business layer. I just give you this information just to have you in your mind, and so that you are with time, definitely it will take lots of time, I would say, okay, to understand all these things. Even myself also takes lots of time, even I'm not that much expert in every level, but it's a kind of to have some sort of understanding that what's really happening and what are the different issues is coming, and how these people, these organizations are dealing with these things. So that's why basically I just put some of these things so that in future and in time you learn something, and if you have any kind of interest to go further, then maybe we can go. Okay, so when it comes now going to little bit um, uh, deeper level, that when it goes to this integration of this renewable energies, okay, sources, how it connects to the network. Okay, you see that's renewable energy is connected everywhere in the network. So from your generations, you have high voltage, medium voltage, LV network. Even if you have some sort of remote connections, everywhere you will have these renewable energy sources connected. Okay, so some of these things in HV you could have direct connections. In MV you could have direct connections, and some space you see you have to connect via. You can also connect directly here, and here is coming some sort of another layer, okay, or another kind of arrangement. We call this, you can put it some sort of microgrid structure of grid on grid, so they can have some sort of connections. So we call it some sort of virtual power plant structure. Okay, we'll come details on this space. Okay, so why we need these things and what are the advantages of these things, or why, what you can do more on this. Okay, so these are the kind of just a broad picture that's to think, to help you to think about these areas that where you can focus on, or why you need these things. Now come to here that at the consumer level. Okay, from network now we come to the consumer. When you talk about these energy active consumers, what really it focused on, and where they're really sitting in the whole system. Okay, if I just say it like this figure, if you see this, if this is your smart grid domain, and that's smart grid covers your smart city, it could be, okay, even multiple cities could be, and within these cities you have different communities. Okay, so that's, you call this smart community or intelligent communities, different sort of means, and just the community, energy communities. Okay, then within this community you have smart buildings. So all these buildings you have to turn into smart buildings. Okay, and within this building you are the consumer, the citizen, which you call the empowering citizens. So all the way how you're linked and connected to the bigger space. So all this space, you have multiple things to do. Okay, and your response here really impact on that. Okay, so how you're part of this smart grid city of your smart home. You see a picture here. Okay, all these things, what you have, and your response really impact on the whole system, and it will. So when you talk this, so what does it mean then? So what really consumer will do actually? Okay, they have lots of more responsibilities. Okay, so I'm just showing some figures and some basic informations for you. I'm leaving it for you just to see that's okay. They will have their own generations. Okay, they'll have their own communication channels and systems and new technologies that should be included. Okay, so the consumers become an active agent and should be able to make decision about the uses of their load while keeping the quality of the energy services provided. Okay, so these are kind of basic information about this active consumer. Now again, come back to the European level, that what European Commission says. All the way, as I show you, that's by 2050, the decarbonization of this network is important, and they are trying to do. And how they will do these things, their main point here is, you see, consumer. So the consumer is the core of this transition. So European Commission says, whatever you do, whatever way you will do, that's no problem, but consumers have to play the main game here. So they have to have the whole right to participate in the wholesale market, energy market. Okay. Or in simple way, if I say it, how one consumer, for example, in Dhaka, okay, one consumer can sell their excess electricity to somewhere in India or in other countries, and another consumer. Can they do it? So that sort of things you have to find it out. So if they want to do, what changes you require? How you can do these things really? Is it possible? You have to make it possible. So that's the EU said this, you have to make it possible. So a customer from one country, if they want, they can sell their energy to another customer in another country. Whether it will be financially feasible or not, that's a different issues. That's another point. But technically, you should be able to do these things. Okay, how technically you can achieve these things? Okay, so that's the core point here. So consumer is the core of these transitions. So you say that consumer are the active and central player of this energy market future. Okay, they will have their choice of supply. Okay, they will have reliable energy prices compressed to the other and producing and sales their own electricity. They should have transparency and better regulations so that they can do these things and respond to the price signal. Okay, so how they do? So that's their point is. So now lots of things happening in this space. That's why people are too much busy with these consumers, their participations, how to make them active, live, and what sort of arrangement could be possible. So initially we were just talking about these micro generation systems, isn't it? So we have our PV, our own place in our home, in our back garden. Okay, we have wind turbine, for example. I'm producing electricity. That's good. That's fulfilling my one of the things. Active, I'm active. Okay, and I have a better choice of my supply. Okay, and possibility to produce. And at some space, I can also sell. Okay, in some space, some of the consumers, I mean, they join together and they install a big turbine in the distribution networks. Definitely, the capacity limit is there, or PV plant. Okay, so that's the way, one of the way they engage together and they connect it to the system, the whole energy networks. So that's one of the way to do also. So what else we can do really to get all other points fulfilled? Okay, the transparency, better regulations, response to the price signals. So the consumer, how much really they produce if they have their own PV, for example, okay, or instance, few kilowatt, 1, 2, 3, 4, 5 kilowatts, something like this, 10, 20, not more than this, okay. And if you see the wholesale market, where all this energy is kind of gigawatt, megawatt range. So compared to these, that how really they can participate? Is it possible? It is possible, okay, some sort of arrangement you have to do. So that's why these days, that's based on the EU regulations, okay, they say this, yes, you have this active consumer, and even it's adopting in most of the countries in the US also, that the active consumers will have their own generations, okay, they can sell or store their energy, participate in energy scheme, and they provide flexibility services, okay. They can join together, they can group together, they can form energy community, okay, where they can generate their own energy, they can trade, they can share, they can supply, they can store, okay, all these things they can do. And when they want to try to go to these wholesale market, there could have a kind of mediator, which is called aggregator, which aggregates all their facilities and then take it to the wholesale market. So that's the kind of one way to do these things. That's good. And that's why this microgrid area is now becoming much more interest. So what is microgrids? Okay, basically when you say this energy community or a smart energy community, local energy communities, you will hear different types of terminologies. Okay, more or less all of these are same. Okay, just so from the physical network point of view, when it comes, it's basically represents some sort of microgrid structure. Okay, microgrid, as you understand, grid and its micro level. Okay, All the way you have your power plant, your generations, your transmission, your distribution up to the consumer. Now in this small space, you can form a kind of microgrid, which because of you have your own generations, okay, you have your distribution network, you have your other consumers, so you can develop some sort of microgrid network here. Okay, then question comes, yes, you can do these things, then you have to maintain your most important issues: stability, reliability, security, okay, these sort of issues. So some sort of protections in your network, because you are connected to the grid, the main grid, so you should have some sort of communication as well. So basically you are producing your the whole, you're taking the same physical structure or the concept or the structure of this whole network, all this smart grid network, and put it into a small place. Okay, so we can start it from our own home. Think about that, how a building can act as a microgrid. The whole picture that we talk about, these integrated energy systems previously, as I showed, the integration of all these energy sources. Okay, we have all these things at our home. We have our own water requirement, we have our own thermal energy requirement, either heating or cooling. We need our electricity, okay, and we'll have our EV, electric vehicles. So now how I can develop or form a microgrid in my homes, or on the other way, how I can treat my building, my home as a microgrid solutions. Okay, so my point here to the students or the researchers, that's think about from this very small place. Okay, I showed you the very big picture from the whole systems point of view. Now replace it and put it into a small space in your home and start with there. Think how you can build up your own microgrid networks. Okay, so that will give you a lot of things to learn and lots of way to uh, move ahead or go to the next level. Now, when you come here, if you see there's here distributed generations are connecting in this distribution network, and that's why power is flowing in different directions, and then the information flow is there. So all these things will happen. So these are the basic structure that you need. You should have communication and control structure. You have electrical network. You should have a local controls. You should have a micro generation control, and if you'll have a central microgrid control structure. Okay, one of the most important point of this microgrid structure is that you should have a single point of connection to the whole grid network. If you think this is your microgrid network, so it should have a single point of connection in the main grid. So you should have a switch here so that you can turn it off and on if you want to work your microgrid in the off-grid mode. Otherwise, you have to have its grid connected mode. Okay, so lots of research also being done here when you decide on how to do these things. Okay, there are lots of protection issues there, anti-islanding issues there. So all these things come here. So I think I'm taking too much time. So I'm just going a little bit quicker to wrap it up all these things. So we'll be discussing on with time, depending on your interest on those things. Okay, different sorts of microgrid structure there. I mean, basically you can have a look on this AC/DC microgrid, depending on the sources you have, and also depending on the frequency, line frequency. By distance, you'll learn about these things, AC/DC and high frequency issues. So all these things happen. So this is just a kind of information about the how the basically when we generate electricity in the certain systems and the bulk systems, how much the cost appears. It's very old cost, okay, but I'm just showing you just as an example that how it varies, okay. So and when it comes to the LV network, the consumer use, how much electricity cost you're paying per unit, okay, and why you're paying these things all the way to get you here. You have lots of losses, you see. So overall, it depends on place to place. 30 to 40% loss appears when it comes to your generations, in the bulk generations, and up to the consumptions level. Okay, but it varies countries to countries even less. So that's why it's the advantage that if you have your own microgrid structure in the community level, okay, that means you are avoiding these losses. So you can consider it here. So there are lots of technical, I mean, the advantages of this microgrid we'll be discussing with time and some other lectures, I believe, with time to time. I'd be happy to share more on these things, but just to give you some sort of quick examples, that's this is a kind of like one form of microgrid. We call this community grids. It's a virtual microgrid. Physically, you don't need to disconnect your whole systems. Okay, if you have your existing distribution networks, then how you can generate or act as a microgrid of this space. Okay, that's what we call this virtual microgrid systems. Okay, you have different sorts of issues there, and technical issues and management issues you have to maintain. So that's one of kind of things. There are other types of things. So community-based microgrid solutions. Okay, you know, this is a micro generation systems. Okay, so if these micro generations are lots, I mean, the few of these prosumers can join together and form a microgrid structure. Okay, that's kind of one kind of structure. So this is off-grid conditions. You should have storage. Okay, without storage, you cannot go to off-grid conditions. So there are lots of other structure as well. This is a kind of virtual power plant. We just recently finished one of the project, one of the biggest project actually is here, finished here with the local distribution network operator and the other SME, industry and people. So it's a distributed energy storage base placed in the residential network and work as a virtual power plant. So we have demonstrated these solutions in the network and shows different sorts of issues from studies the technical issues and how it benefit to the customers and the consumers and to the network operators, how the this structure can provide some service to the network operator in terms of the grid stability and power quality issues. I am just escaping these things as I believe, I'm not sure if the time permits, or just quickly wrap it up. How would you like?
Uh,
I know.
I think that, I mean, how long it may take overall if you continue all the slides?
I think 5-10 minutes more.
Yeah, no problem. So please
Okay.
continue. I mean,
Okay.
it's
Okay.
better that, I mean, you present everything you planned.
Okay.
Thank you.
Okay.
Yeah.
Okay, that's fine then. Okay. I'm just quickly, I mean, the showing these things just to give everybody's kind of lots of points to think about it. Okay, if anybody feel any interest to work in these areas or anything, and yeah, I'll be happy to share and collaborate more in this space, no doubt about it. So yeah, just but these are not all. There are lots of other issues that I just skipped. So as the time is not there, so it's one lecture is not really enough to go. But for every topics, we will have multiple lectures, you know. But we are not going on that direction. So this is just showing something that how really PV generations, if you have how it works or how it impacts on the networks. Okay, you'll have always a voltage rise when you inject lots of active power from the PV generations. Okay, and you have some sort of control that you can apply so that it really manage the voltage in the network, but allow you to inject more from the PV generations. This is some sort of just to give you idea, I mean, information that from different sources, what type of power quality issues that could rise. And yeah, just to give you some example. Okay, like in a university building, this is one of the research paper from others that shows that if you have lots of harmonics generated from the desktop PCs, okay, and in a house also, so how much really is consuming these losses? I don't know how much you're familiar with this THD, total harmonic distortion issues. There are some sort of IEEE standard and European standard as well that you have to follow it. Okay, but why you are talking about this power quality and grid stability issues? Okay, maybe in our countries I think so we heard in your you heard in your last lecture about this blackout. Okay, that's one of the things. But even if you just think it's a very small power quality disturbances in whole Europe, how it impacts 150 billion a year in their business. Okay, just very small power quality disturbance if that happens. So this sort of things happen. So to improve the network stability, there are lots of issues that have to take care on, whether it's in microgrid, whether it's not, whether it's in the distribution networks. You have this sort of grid stability issues will come, and you have to have different sorts of method to improve these things. So just to show you that's big area, lots of things to do depending on your interest. And yeah, that you can carry on. So there are some sort of other issues about this filtering, active power filter placement in the network, or the grid stabilizer you have to put. So that's from the research point of view. Now, just to show you a little bit about these research opportunities in Ireland, and especially in the European countries. As I said, they're investing billions, okay, euros. And there are lots of opportunities, I would say, in European countries, from the masters, from PhD, from postdoc, from experienced researchers at different level. Okay, and they have lots of program around the year. So you can, I mean, just if you have any interest, or let me know if anybody is trying, and I can share you more on these things. This is just recently I'm just showing you about one of the interesting project in EU. That's from the Horizon, I mean, the European funding. That's, they call it Microgrids. They have 22 physical labs in 13 countries in EU. They come up and join together, and they form this type of networks where you can apply, you can develop, I mean, the project idea, and you can go there and do your experiment. They have very good high level research lab in their space, and this is a kind of collaborative research works. They will be providing all types of financial support for your travel, for accommodations, for everything, and they're happy to do these things. So they have call yearly 4 times. Still, one call is there, so next call is coming also. And they also have this year, because of this COVID issue, they have the free access to the virtual facilities as well. So if anybody interested to like to think for a collaborations or visit to Europe for maybe 1 month or a couple of weeks to do any kind of some sort of good research work, so you can have a look on these things. Okay, they have, though most of the things are they made for EU people, but they have 20% of their facilities, I mean, their support is for the non-EU people. So that's, you're welcome. That's within this 20% categories. Okay. This is something for the from the Ireland, as I'm here. So Irish government have every year, they have good amount of postgraduates for masters and PhD, and for postdoctoral fellowship as well, and other experienced researcher level as well. So that's also available every year. This year it will comes in the September, October time. So if anybody have any interest, let me know, or if you can, yeah, I'll be happy to help in this regard as well. So that's one of the things. This is one of the prestigious fellowship, I would say, from the EU. Marie Curie fellowships. That's for the postdoctoral fellowships, basically after PhD. So those who have some sort of good experience and high quality research work, they can yeah, come here. That's very, very prestigious and very good, I would say. Okay, so those who have finished their PhD and have yeah, 1, 2 years, 3 years experience and more, and want to stay in Europe for 2 years, and they can try for this. And this is highly competitive. Okay, but it is one of the best, I would say, and very much financial support as well. Very good financial contribution. You'll get support from them. So that this not only this, I mean, there are some other places also. So in Ireland also we have, as I said, this around the year we have different calls from the government for different types of projects. Last month, sorry, last week I just finished one, submitted one called proposals, actually says, as this is our way to live here, apply for competitive funding for different projects. And that's the way we work here. We have different types of project in our group right now. So, and these are working, as we said, this funding from different sources. So some of our own funding, some of our industry partners funding, some from the government, joint funding, some from the EU fundings, okay? So that's my group have some interest as currently as we are working in different areas, as is mentioned. So right now, yeah, I have 2 postdoctoral researcher and 2 research assistants and 1 PhD in my group. So yeah, that's the things we are doing, and we'll be happy to, yeah, learn more about your interest and your future interest as well. So happy to share with me if you have any kind of interest in these areas, and just let me know. And yeah, I'll be happy to have more support as much as possible. Okay, so yeah, I'm just finishing here. Okay, that's just kind of 2 called right now. I have one for the book. I'm just working as an editor for one of the book from Elsevier on these active power filterings, and also a kind of editor for this one of the issue for the energy journal. So yeah, that's I think all from my side. Thanks a lot. I'm sure I believe it will help at least a little bit. If it helps, then really that's my success, I would say. So yeah, I'm not stopping at this moment, leaving it with you and the audience. Any kind of question or any kind of queries, please.
Mainul or Asif. Yeah, thank you so
Yes.
much. So, Mainul or Asif, you could just handle the QA session, please.
Yes. Thank you, Shafi Bhai. It was a very thorough, very good presentation, because in our group so far, what we have started, we have not seen this part of the power system. On the last 2 lectures, we did a little bit. So thank you for that. So এখন স্টুডেন্টরা তোমরা feel free to start any discussion. যদি মনে করো কিছু ডিসকাসও করতে চাও, start on it in the form of question or whatever.
Yeah, feel free. Any types of questions or anything, any comments, good or bad, whatever it is, feel free, please.
So
yeah,
I think we have a question from Monir Bhuya. So could you please unmute yourself and then introduce yourself and then ask your questions. Yeah.
Thank you very much. I think introducing, I'm from UK, so ex applied physics student, know Atik and Dr. Khadem and Dr. Ahab very well. So I think that's all about, I don't want to waste too much of your time. So basically just a quick question. I joined a little bit late, sorry for that. My question is about very much tech entrepreneurial side, more in the implementation. So when I joined, I noticed, I saw Dr. Khadem was showing like microgrid and how it will be linked with a smart grid. So I was thinking like, okay, if you think like the U campus and you have different building, how about if we do this small microgrid to the smart grid? So this is like a, can be one plan. I think that's one question. Is it possible, Dr. Khadem? Number two question linked with this, what sort of, I think it's more with people who are living in Bangladesh now, what sort of support or like, one is financial support and also like with the national grid, what sort of support you would get if you do this sort of project. So I can link my experience with that. So in my house, I have solar panel. I know how much I can produce from my house. I produce in a very sunny day in the United Kingdom. It is maximum 22 kilowatt. It can go down to 7 kilowatt. So my belief in Bangladesh, because we have most of the time minimum 11 to 12 hour sunny days, it will be more. So I think there's more prospect. So I'm just closing it down. Number one is it possible to make this smart grid, starting from microgrid to smart grid in Dhaka University campus? And second is, if we do this, is there any things which can be linked with national grid or financial system in Bangladesh?
Yeah, thanks. Very nice questions, Munir. I would say that the very first point is yes, of course, it is possible, and there are lots of examples. I think around the world, and in UK you'll have lots of examples of these things that the university campus is already part of their university campus is running by the microgrid solutions. I think most of the university have these things in UK, and also in the experimental level there is. So there is nothing, I mean, the new or nothing is impossible from that side. Okay, so even if we can in our Dhaka University, you can start from our buildings, the applied physics, right now it's a IEEE department. So think about this IEEE department, how you can develop your own microgrid solutions. I think it's a very good start, I would say. I'd be more than happy to support in this space, where it is required. So that's from the technical side, from the any other issues. And that will be very good, I would say that's for the department, to make it as a living lab. Okay, so I don't know how much you are familiar with this living lab idea. The living lab idea is the real life demonstration of any kind of solution, at the same time doing research on that solutions. So that's a kind of this living lab facilities, and that's very much demanding, I would say, in everywhere. So if we can do these things, that will be really good from every sense, from the research point of view, from their own buildings, own infrastructure point of view, and for the future, getting some future fund as well. I mean, that's really valuable, I would say. Okay, in Europe, it's really very much valuable, and I would say that's in Bangladesh it will be also. By the way, I just share with one point here. That's as we don't have much facilities in our country, in Bangladesh. Okay, that's, I would say that's in Europe, that the funding opportunity that I talk about, this Horizon Europe, okay, right now this. So Bangladesh is part of, I mean, is also considered here in this cases, I mean, the associated country. So India have lots of participations in Horizon, in Horizon 2020 and now in the coming. So I would say that Bangladesh have also this scope. I think it's only just lagging of knowledge or information that people don't know about these things, but I'd be happy to share more of these things here. So you can join and try to participate in different project proposals and look for funding. And that's really a very good support, I would say, if you can develop these sort of things. That's one thing. The second question was that's how it's very much possible to connect with the national grid. And I think there's nothing really to protect it. I mean, they are prevented to do these things from the government level as well. So it's very much possible. And from the excess electricity, that's right now I don't know. I mean, whether we have any kind of mechanisms to our country in Bangladesh to sell this electricity to the grid or not. So these things should now come up. Basically, I know some of these things happen in our countries, but I don't want to go on that directions right now. But there are lots of bureaucratic problem and lots of corruptions also. I'm sorry to say these things, but yeah, some initiative should be taken. I think the Energy Institute of the university, where I was there actually in the Renewable Energy Research Center when it was. So I had the opportunity to do some research work that time, but now they have very good established, I think, and it's growing up. And yeah, lots of things they can do as well. I think some our teachers also from our department also involved there. So yeah, that's very much doable and possible. I think that's the answer. If it is okay, or if you need any more, please, yeah, let me know. I'll be happy to share.
Thank you very much. I think I can add one thing. I think in UK, Liverpool started a project called the Smart City Project. And also in the UK, and there is a scheme called feed-in tariff, like Labour created this national add energy in national grid, and the government give this money back. But again, that's something I think our future generation can replicate in the projects if they plan something.
It's all about the policy. Thanks. Sorry. It's all about the policy. The government should have this sort of policy about this tariffing systems, feed-in tariff systems, which you don't have in our country. So, but it needs a strong network as well. As I said, there's lots of stability and the power quality issues will arise. So so there are a good amount of, I would say, research required. So I would encourage our department and students to think about this as well. Okay, that's a very good point. Yeah, thanks. Anybody else?
আসসালামু আলাইকুম, আমি রুমানা রহমান। আমার যদিও মনিটরের নামটা আমার ভাতিজার নাম, ভাগ্নের নাম রুমানা রহমান। আমি অ্যাপ্লাইড ফিজিক্সের অ্যালামনাই, বর্তমানে নর্থ সাউথ ইউনিভার্সিটিতে আছি ইসি ডিপার্টমেন্টে সিনিয়র লেকচার হিসেবে। তো থ্যাংক ইউ ভেরি মাচ ভাইয়া, আপনি ইট ইজ ভেরি নাইস প্রেজেন্টেশন, আই এনজয় থরলি। তো থ্যাংক ইউ ভেরি মাচ। Now the question from my side is, I love Dhaka University campus. I have been waiting for a time when Dhaka University and some other universities can collaborate on a big project where really data from multiple sites are needed and it can be useful. So for very future, can we think like যদি আমাদেরও নর্থ সাউথ ইনশাল্লাহ কিছু ল্যাব সেট আপ হচ্ছে, তো ভবিষ্যতে যদি অন্তত আমরা কিছু ডেটা পাই বা ডেটা জেনারেটও করতে পারি, তো কোলাবোরেটিভ ওয়ার্কের জন্য ইনশাল্লাহ, মানে আমার তরফ থেকে আমি বলে রাখলাম যে ইনশাল্লাহ নর্থ সাউথ টিম উইল বি ভেরি হ্যাপি টু collaborate.
Yeah, just I mean, for everybody, we still have overseas participants, so we try to ask any questions fully in English and answer in English as well.
Oh,
yes,
sorry.
thank you.
Sorry, thank you, sir. Thank you, sir. So yeah, it would be great to collaborate with Dhaka University, especially in the smart grid field. And I think a start point can be offering or giving the idea for undergrad level little projects, so students can learn about the tools. Then later on they can work more, thinking about taking up a thesis in their undergrad final project, like capstone project. So if we can get some ideas what kind of little projects we can offer to our students, I think we can begin with that. Once we get a good number of students in our collection, that will be also a strength.
Yeah, that's really a very good point. I would say this, and I really like it. So I'd be more than happy, truly, to provide as much as possible support from my side, especially, I would say, and I'd be more than happy to collaborate as well. So, and for these students, as I said, this we can have lots of. Truly speaking, the ideas and support that we can provide, but all the way we have to ensure that you will be doing these things, or you have to maintain your time and track. At the very beginning, as I said, this research is all about the passion. If you don't have any kind of passion, then you really can't do. I mean, it's not just to get your marks and finish. That's it. You don't. If you think it in this way, then it's not possible. Okay, then it's better not to do it. So I'd be happy, and we can discuss more about these issues and in the coming days. And feel free to contact me for any kind of ideas and topics, and what type of resources you can have. I mean, I can provide some sort of, I mean, the any types of resources in terms of these publications and journals, accessing all these things, even some software tools that you can freely use. That's, I can also suggest some of these things. And also, truly speaking, I have some interest also to, I mean, the support as much as possible to build up these lab facilities also in our country. So feel free to choose. As I said, this I just give you the broad, some sort of broad picture in different space in the network. So depending on your interest, and we can go further details in our choosing any topics specific, for example, related to the distribution network. If you think something to do with this, microgrid structure, something with the community grid structure, so some sort of power quality issues, if you think about to go on that, or develop some real lab facilities and living lab experimental facilities. So just choose, and I'll be more than happy. As I said, I think I just share, I mean, just a couple of idea I just showed in my last slide. I think just as I said, that's some things in broad space, but there are a lot of things to do within this space. As I said, this community-based microgrid virtual power plants, so the grid stability issues. So these are some of these solutions that we are thinking, and also the power converter designing for these first charging EV solutions, and the energy storage for the grid services. So these are right now, actually, we are working in some of these, I have some of these projects, and also I have my own interest as well. So I'll be happy to have any kind of collaborations and communication. Just let me know, please, if it is okay, or if you want me right now to have some sort of specific ideas or more than this.
I want to just add, this is Asif. I want to add one thing just on that point. Thank you for bringing up that point, Ms. Rumana. And we already actually have, like you said, it's a very broad topic. We can venture out in many different ways, but there are 3-4 projects that I gave as a starting project. It is exactly based on campus microgrid, and it covers power quality protection and design, renewable sources, and feasibility of automation and all those stuff. So I'll be happy. The main thing is that we are trying to motivate students. Unless the students are interested and start working, then we together can do research. That's always possible. But I want to emphasize that students should get interested and start working with us. But I am open, and I'll talk more about at least both of you two about those projects. That at least let's start trying to get students in our loop.
Thank you very much, sir.
Yeah.
Thank you.
Yeah.
Yes,
That's
we
really
do have
important.
some. Yeah, we do also have very good students, so they just need some good platform. So
Okay.
getting supervision from different entities will be a really good experience.
Yes. Yes.
Thank you.
Yeah, that's yeah. Thanks, Rumana. Yeah, please do communication with us. So my email address and the other information is also there. So yeah, feel free. As yeah, as I said, that I have actually last year actually I have a couple of master's students also have finished their thesis. And because basically we are linked with infrastructurally linked with one of the university here in Ireland, Cork. And I also have collaborations with the University of Bradford in UK also. So they have finished two collaborative master's thesis as well last year. So yeah, one of the guys is now also working with me in as a research assistant in one of the project. So there could be a good opportunity, I would say, there's for experienced researcher and student as well in the at any level. So yeah, that's all from my side for the time being, I think. Yeah, any more queries or question? I'll be happy to answer more. No problem if you.
Habib sir is also here with us. Maybe I think he
Assalamu
joined
alaikum,
late.
Habib.
Walaikum salam. How are you, Khadem?
Alhamdulillah.
I want to add something that the
Please.
government of Bangladesh has already finalized its feed-in tariff rate.
Oh, great.
Okay. And
Great.
Dhaka University is
Good
going
news.
to adopt a big project of rooftop PV generation system. Actually, we want to cover all buildings of DU campus
That will
with
be really
PV
great.
module. Okay.
That will be really great news. I mean, so I'll be more than happy. Habib bhai, sorry. Sorry, sir. Yeah, we'll discuss more maybe, inshallah.
Okay.
I'll be more than happy. Yeah, yeah, I'll chat with you. That's really good news, I would say. Yeah. And yeah, basic feed-in tariff actually the very first thing that to encourage the consumer or the customers to be active
Though
in
the
this
rate
network.
is not fixed, you have to negotiate with the government. It may be 10 cent or 11 cent maximum, depending on the cost of the project. But it may be also as low as 4 cent.
4 cent US dollar?
Yeah, US dollar.
Okay, okay. Okay, but how I think in Bangladesh now the production cost is very low, I would say.
Yeah,
It should be.
exactly. Because the
Yeah,
price of the PV cell, PV panel
yeah,
has already been down, very down. Maybe
yeah. It's below $1.
25 taka per unit per watt, 25
Oh my
taka per
goodness.
watt.
How come it's possible? It's too
Yeah,
too
this
cheap.
is due to the production in China.
Oh my, that's too cheap. Yeah, I surprised really. I mean, there are now a couple of very big projects in Middle East and also in Europe actually.
In
So
Bangladesh, we have also many big projects. For example,
yeah.
20 megawatt solar photovoltaic system, 10 megawatt solar photovoltaic system already running on.
Okay, so are they selling to the grid or is
Yeah, exactly. Selling to the
okay.
government through national grid.
Okay, that's really great. I would say that's yeah. So its price is now very much going down, so we can easily actually do some sort of work there and develop some facilities and do some real world experiment as well. So I don't know. I would request one thing, if possible, Habib and anybody else who are involved in this type of projects. So whatever the pilot projects is trying to run in our country, if it is very much important to include some sort of measurements facilities as much as possible. So
Yeah,
that's
yeah.
really
In
important.
our Institute of Energy, that was previously Renewable Energy Research Center, has a 3 kilowatt, maybe approximately 3 kilowatt grid tied system. And they are acquiring all types of data from that system.
Because data is really valuable now.
Yeah.
In anywhere, data really talks a lot. And this data, I mean the data analytics, that's one of the booming field, I would say. So data science and data analytics. So that comes to the machine learning issues. So all these are really very much in advance, and it's basically the whole power system is heavily dependent on these areas as well. So good opportunities for that side as well. But as you said, this for our cases for research, this data is really important. So I would request for everybody who are involved or will be involved in future, try to get these things. So as much as possible, the power qualities issues data and the others, all this measurement. So that's really great. Nice to learn about these things. Actually, yeah, I'm trying to be involved from now on as much as possible. So yeah, I'll be happy if anybody else or anybody is interested. So yeah, keep me in the loop and touch. Right. Thanks. Anybody else from the student? Don't feel shy. Okay, you have to be vocal, you know, whether you, I mean, that's your learning stage. If you don't say anything, you can't, I mean, it will delay in your learning. That's the thing is. So please feel free for any kind of comments, any kind of queries or anything.
Yes, students, please ask any questions or comments. Especially, I wonder why don't you ask it, especially on the scholarships, funding issues, which he mentioned, even to visit for 1 month or something like that, on cooperative works as well. So please ask whatever you want to ask.
Yeah, that's very important. I would say that's it's for everybody actually think about. As I said, this Europe is really investing a lot in research and innovations. So it's just to look and find it out in the right place in the right time and grab it. So very good opportunities. It's from every level. Okay, they have, as I said, this is from the students, master's, PhD, from the post PhD, postdoc, even the experienced researcher. Okay, everybody have their different sorts of mechanisms and program. Some lots of exchange program as well. So there are good opportunities. So please feel free for any kind of query or anything if you have. Okay. And in any areas, if you feel that you're interested and if you need any kind of suggestions or support from my side, I'll be more than happy to provide everybody any things. So yeah, that's all I can share from my side. So whoever else want to contact with me, just yeah, contact. My email address is there, and also other I mean if anybody want to connect in the LinkedIn profile as well, most welcome. And I will say that LinkedIn profile is one of the good from the professional side, as you will get lots of if you're connected, you will get lots of relevant informations in areas. And very last point, I would say that's not the very last, very important point. I would say this is now the life is becoming very much diverse in different directions. Okay, whether you are being expertise in one particular areas or particular topics, but remember that's in these areas that as you see this now, it's integrated energy systems approach. So that means a lot of things are connected in your systems. So even if you are very much expert in, for example, converter design, power electronics, okay, but try to learn the whole network issues, at least for your good understanding, so that you can, that will motivate you and help you to work more. And truly speaking, in this now these job areas, this not only for job but for any kind of research and getting experience. So people are always looking for some sort of good experience or knowledge in a kind of surrounding areas as well. So that's really important. Okay. So that's I would suggest you to grab this is the time now. You're growing up, so with time definitely you'll learn more. But yeah, that's always still I'm learning myself as well. So that's the way.
So if no
So
one else has a question, I want to ask one. If quickly,
yeah,
if
please.
just give me just a quick answer of uh, are is you showed about a lot of things going on with the research institute and in the UK, Europe. So what about how much is really they're thinking about DC microgrids? Is it
Yeah.
something considered, or how? What is the status of that if it is
E-
something important
No,
considered?
no, no. Yes, yeah. I did not go any kind of details of these different types of microgrid structure in terms of DC, AC, or high frequency it is. But yeah, though mostly, I mean, right now, normally people are working in the AC microgrid solutions, but DC is really getting importance as well. I mean, not everybody is doing, but in different space in Europe, I would say they are much focusing on the DC side as well. Okay, and things are changing. Okay, as you said, this yeah, people may say, think about one question just come to my mind. That's when you talk about this transmission network, high voltage networks. You know, high voltage is always DC. So that's important for the for question for the student actually. Okay, why this transmission network or high voltage networks is DC? Well, we are using its AC. Okay, so just think about it, and that's very basic questions, but very nice answer, I would say. But yeah, from the LV networks now, lots of work really going on DC because the most of the appliances now have some sort of DC connections. All these I mean, the appliances, smart appliances that people are using, they are from the DC source. So that's why the internal network, I would say that's like microgrid network or in buildings. Okay, these are changing now with DC in lots of places. Okay, and people are doing in this. But as it is said that the whole network is not possible to change from DC to AC, from AC to DC, the whole distribution network. So it's not possible. I mean, it's possible, but it's not logical. So that's one of the things that has to be considered, and that's they're doing. So, but within these microgrid areas, you can play with the DC. That's absolutely very good and very much good solutions. And lots of places they are doing these things, truly speaking. Okay. And even in the last year, I would say there's a big call from Horizon Europe, European funding call also from these microgrid area, the AC/DC solutions, in even hybrid mix of AC and DC solutions. So they are doing a lot of things in this area, no doubt about it, I would say. Okay, I know that's one of the biggest, I mean, the most renowned facilities in Europe. That's in the Aalborg University. If you just Google it, you can see it in Aalborg Microgrid. That's one of the renowned in, I would say, not only in Europe and globally. They have lots of facilities in the ACDC microgrid solutions, and they are doing a lot of things in these areas. Okay, so yeah, I have a good connections as well, so from with them. So yeah, so it's not like that we're not doing, but yeah, I would say that's for our from our country, that's also very good solutions will be. I mean, especially in the rural remote areas,
Mm-hmm.
that
And
will be
also the
very good,
geographical
very good.
area is
Yeah,
small. Yeah.
yeah,
So
exactly. That will be very good solutions. So plenty of things to do. Yes, you have to choose and start working in real. But one thing I would also encourage, it's not only the students, for all those who are involved in research, how you can really commercialize your research. That's really very important. Okay, so think about everybody. So how your research, whatever you are doing, at the end, if there is any possibility to commercialize your product. That means that whatever you are doing, is it possible to come up as a product or invention something? This product means it's not only a physical product, physical device. It could be a hardware, it could be a software, it could be a service, different sorts of things, some innovative solutions. Okay, that's really value in Europe. Okay, they're very much intellectual property issues are implemented here. Okay, IP issues. So and also that's really important. So that will give you, like, they encourage to go for, from your research, to go for a spin out a company, do some business, these sort of things. They're really encouraged a lot. So that's really good. That's motivates the researcher, I would say. Even a couple of years before, I also did not have that much intention really to go or to think about this. But I find that it's really important for any researcher, that motivates, that whatever you're trying to do, if you can come up with a kind of real solution and do some real, so that industry will come to you and take your product as an IP, with some IP, and then yeah, that's really a big value for these things. Just keep it in mind. So yeah.
So anyone else? Still a lot of people, a lot of students.
I think everybody's very tired listening. So no problem. So take your time and take rest. Maybe, anytime for any other time. So just have any kind of questions or queries or interests. If you feel free to communicate with me, I'll be more than happy to share anything.
Shafi bhai, can you also prepare a PDF of the slides and send it to me so I can have it uploaded?
Yeah, I'll do. Yeah, sure, I'll do these things. Yeah, so I gave you here different issues and different topics, kind of broader ideas, but I'll be happy then from the students, or the IEEE student branch, basically. So depending on your interest, if you think that if you want to learn more or listen more from me, just feel free to share with me the topics that is specific on these things, or any other things. I'll be more than happy to share more. Okay, to go into step by step or details, the technical, if you need. Okay, so just feel free to share it. So yeah, I'll give my I think you have everything's my details and everything. So yeah, that's all I would say.
Okay, so shall we conclude? Anyone else? Probably. If nothing, then thank you very much, Shafi bhai especially, and then all the participants and all the guests. Thank you very much. And until next time, goodbye.
Yeah, thanks for allowing me to give these presentations, and yeah, thanks everybody for having their patience to listen all these things, bored things maybe.
No, it's wonderful. I mean, one thing is that it will be uploaded in the YouTube. I mean, so there is no problem, right?
Yeah.
Yes.
Okay. Thank you. So you can stop the recordings, students.